In our lesson today, we're going to have practice with logarithm equations. And a logarithm is the power to which a number must be raised in order to get some other number. The common log is defined as log x, where the base in this case is log base 10 of x. Okay, and so an example of this, log 100 is equal to 2 because 10 to the second power is equal to 100. So if it just says log of a number, it's understood that that's going to be base 10. Okay, and so that's what we have down here in this example, log of 100, that's base 10. Well, again, they're asking you here to figure out what value that's going to be. And if we think about that in terms of exponents, that means my base of 10 is being raised to some power, and the answer is going to be 100. Well, in this case, we know that 10 has to be raised to the second power in order to equal 100, and so that's why log base 10 of 100 is equal to 2. This value has to be equal to 2. In this example, log of 1/1000th is equal to some number. So again, we have a base of 10, and so we're asking ourselves, okay, 10 to what power is going to have to be equal to 1/1000th? Okay, well, using our exponents, we know that 10 to the third power would equal 1000, but in order to make this fraction 1/1000th, we're going to have to take a reciprocal, which means our exponent's going to have to be negative. So 10 to the third power gets us to 1000. 10 to the negative third power gets us to 1/1000th. And so in this example, the value of x must be -3. In our next example, log of the square root of 10, again, is going to be equal to some unknown number. And once again, we have a base of 10. So 10 is being raised to some exponent, and the answer is the square root of 10. Okay, and remembering our rules for exponents and square roots, this exponent is going to have to be equal to 1/2. The exponent of 1/2 in this case, 10 to the 1/2 power, is equal to the square root of 10. And so when we evaluate this logarithm, the value of x is going to have to be 1/2. Now, some helpful logarithm properties that are going to be able to be used to help us solve some problems. When we have two bases that are the same, okay, log base b log base b of a plus log base b of c, I can just rewrite this as a logarithm with the same base of a times c. I can take these values and multiply them together. Once again, if I've got the same base and I'm doing a subtraction, log base b of a minus log base b of c is equal to a logarithm of base b, this time of the quotient a divided by c. If I have some number multiplying a logarithm, a times log base b of c, I can just rewrite this as logarithm base b of c raised to the a power. Whatever this number is here becomes the exponent of that value c. And then this one right here is probably the most important in my opinion. It's going to help us change bases. If I have log base b of a, all I have to do in order to evaluate that is take log base 10 of a and divide that by log base 10 of b. And so I'll show you an example of what that looks like here in question A. 2 to the x power is equal to 8. Okay, I'm going to write this in log form first, and then I'm going to evaluate what this value of x is supposed to be. So 2 to some power is equal to 8. If I think about that in terms of a logarithm, that's going to be log base 2 of 8 is going to be equal to some exponent. I'm trying to figure out what that exponent is. Okay, so I'm not base 10 anymore. In this example, I'm base 2. In order to evaluate this, so I'm going to look at this rule that I've got right here, log base b of a, I'm going to do log of a divided by log of b. Log base 2 of 8, I'm going to do log of 8 divided by log of 2 in order to figure out my value of x. Okay, and so I can use my calculator here. Let me pull this over. All right, I'm first going to type in log of 8, so log of 8, close the parentheses, divided by log of 2, close the parentheses, and that gives me a value of 3. And so I know then that this answer is 3, and the value of x must be 3, and that makes sense. We know 2 to the third power is equal to 8. In example H, it says 3 to the x power is equal to the 5th root of 9. And so in log form, that's going to be log base 3 of the 5th root of 9 is equal to x. So I've got my equation set up, the logarithm of the 5th root of 9 divided by the logarithm of 3. And I'm going to use my calculator to figure out what that value is. So I'm going to start by doing the logarithm. And to do the 5th root, I'm going to push 5, and then I'm going to hit the math button. And then I'm going to use this choice right here, number 5. Okay, and that gives me my 5th root notation of 9. And I'm going to close my parentheses, divided by the logarithm of 3, and equals 4/10. Okay, and so the value of x in this case is going to be 4/10. In the next section, it says to solve for x and round to the nearest tenth if necessary. And A says 4 to the x minus 1 power is equal to 5. And to help me answer this, I'm going to write it in log notation. And so I'm going to write this as log base 4 of 5 is equal to my exponent, which was x minus 1. Okay, and so I'm going to try to figure out what this value of x is. Okay, so I'm going to have to get x all by itself. Well, on the left side, I'm going to evaluate this first. This is going to be log base 5 divided by log base 4, or excuse me, log of 5 divided by log of 4, and that's going to be equal to x minus 1. Okay, and if I punch this into my calculator, the log of 5 divided by the log of 4 is equal to that decimal right there. So I'm going to write out that value. 1 and 160964047 equals x minus 1. Okay, and to get the value of x, I'm just going to add 1 to each side. So x is going to be equal to 2 and 160964047, which is going to be approximately to the nearest tenth, 2 and 2/10. In example B, we have 1 300ths raised to the x over 2 minus 5 power, and that's equal to 2. And again, I'm trying to solve for x, so I'm going to write this in log form first. This is going to be log base of 1 300ths of 2 is equal to my exponent, which was x over 2 minus 5. And so again, I'm going to see what this left side is equivalent to, and then I'm going to use my algebra skills to get the value of x all by itself. So I'm going to have log of 2 divided by log of 1 300ths, and again that's equal to x over 2 minus 5. Log of 2 divided by log of 1 300ths is equal to this decimal, 23 and 449772225, and so I now know that that equals x over 2 minus 5. Okay, so the first thing we're going to do is we're going to have to add 5 to both sides, which is going to make this 28 and 449772225, and that's just going to be equal to x over 2. All right, and now in order to get the value of x, well, I'm going to have to multiply both sides by 2. So I'm going to do 2 times that whole number. So let me add the 5 and then multiply by 2. And so x is going to be equal to 56 and 8995445. And again, we're rounding to the tenths place, so it's approximately 56 and 9/10. In example C, we have 6 times 3 raised to the x plus 2 power, and the answer is equal to 48. And the first thing I'm going to do to make this easier on myself, I'm going to go ahead and divide both sides by 6. Okay, if I divide by 6 on both sides, I'm left with 3 to the x plus 2 power is equal to 8. And this is nicer now because I can write this in log notation. So I have log base 3 of 8 is equal to x plus 2. So I'm going to go ahead and write this as log of 8 divided by log of 3 equals x plus 2. And when I punch this into my calculator, I'm going to have log of 8 divided by log of 3. And I'm going to get this decimal here, so I'm going to move this over so I've got a little more space. Okay, and so I'm going to write that decimal down. I have 1, move that calculator, 1 and 892789261 is equal to x plus 2. Okay, so to get the value of x all by itself, I'm going to have to subtract 2 from each side. So if I subtract 2 from this number, x is equal to negative 0.1072107393, and rounding it to the nearest tenth, it's approximately negative 1/10. In example 3, we're told that the population of Red Hook is growing at a rate of 3.5% per year. If its current population is 12,500 people, then in how many years will the population be 20,000 people? Round your answer to the nearest year. And so what we're going to have to do is set this problem up algebraically. So what I'm going to do, I'm going to take the current population, which is 12,500 people, and since it's growing at a rate of 3.5% per year, I'm going to multiply that by 1 35,000ths. Okay, the 1 represents the 100% of the current population. The 35,000ths represents the 3.5% increase per year. And I'm going to raise that to some power in order to figure out when the population is going to be equal to 20,000 people. All right, and so to figure out how many years, I'm going to have to figure out what this value of x is going to be. So the first thing I'm going to start by doing is dividing both sides by the 12,500. When I do that, that leaves me on the left with 1 35,000ths raised to the x power. And if you do 20,000 divided by 12,500, you get an answer of 1 6/10. Okay, so now we can write this in log form. We have log base 1 35,000ths of 1 6/10 equal to x. Okay, so I'm going to set this up now. I'm just going to write this over here where I've got a little more space. I'm going to do log of 1 6/10 divided by log of 1 35,000ths, and that's going to tell me the value of x. Okay, so x equals, well, if I punch this into my calculator, log of 1 6/10 divided by log of 1 35,000ths. Okay, that gives me a decimal 13 662322956. Okay, the question said to round your answer to the nearest year, and so this is going to be approximately 14 years. It'll take about 14 years for the population of Red Hook to reach 20,000 people.